Okay, so today we are going to solve part of an AP problem from 1975 that involves terminal velocity, air drag, drawing good old free body diagrams, and then we're going to go ahead and set up some differential equations and solve them. Great. So go ahead, what I encourage you to do for everything on this screen, go ahead and pause this video, solve this all yourself, and then check back in. Cool. Okay, so now that we're back, let's go ahead and go through it together. So we have a sphere of mass m released from rest. As it falls, the air exerts a retarding force on the sphere that is proportional to the sphere's velocity, Fr equals negative bv. On the circles below, draw vectors representing the forces acting on the sphere. So for I, just after it's released, okay, so we know gravity always acts on things with mass. Ooh, sorry about that. Crazy screen. Okay, great. So we have gravity right here, which is just going to be mg. Cool. The, let's see, retarding force is going to be going the opposite direction. Just after it's released, the velocity is going to be pretty small, so it's not going to be too big of a force. I'll put that on here. So for 2, we want to find it, we want to draw a Freebody diagram after it has been falling for a long time and reach terminal velocity. And then make sure to label your vectors. Okay, when something reaches terminal velocity, that's when all the forces are balanced on something, so the F net is equal to 0, or I should say when it's falling, that is. So we know that the air resistance force or the retarding force is equal to gravity. So let me make sure my arrows are about the same size. We have Fg equals mg. Fr equals negative bv. Great. I just love drawing Freebody diagrams. They're so fun. Cool. So now let's go ahead, write but do not solve a differential equation for the instantaneous speed v of the ball in terms of time t as the ball moves downwards. Great. So for these problems, we're always going to say the downwards direction is positive. So I'm going to go ahead and set up F net. So F net is going to be equal to, let's see, whoopsie, sorry, I have updates coming up. The forces acting on it. So we have gravity, take away the retarding force. Great. F net we know is always equal to ma. Fg we know is mg in this case, and it looks like it's small m. Take away air resistance, retarding force is bv. And I didn't add a negative sign in there just because I don't want gravity and Fr to be like the same like sign. I want them to be the opposite signs because they're pointing opposite directions. Cool. So I have that. Now let's look at this. So I need to make this into a differential equation. So are there anything on here that's not constant? M's always the same. G, acceleration due to gravity, is always the same. B is a constant. Velocity, okay, velocity is changing. And acceleration, that is going to change as well. Acceleration will start as g meters per second squared, and then it'll eventually go to 0 meters per second squared when it reaches terminal velocity. So we can write in for acceleration as dv dt. It changes as a function of velocity. So that equals mg minus bv. Great. Okay, so now what we're going to do is we're going to solve the differential equation in part B to find the velocity of the sphere as a function of time, showing all your steps. Great. So let me just pull out my equation. So we have m times dv dt, and again, this is the one we just figured out, equals mg minus bv. Great. So first thing, and honestly there's like a zillion ways to do this, is we need to separate. So we need to make sure anything dealing with dv and v are one side, and anything dealing with dt and t are the other side, okay? And the only thing to keep in mind, to move things from side to side, we can only multiply and divide because everything needs to be multiplied by dv or everything needs to be multiplied by t, okay? And dv and dt need to be on the top. So first thing I'm going to do, I'm just going to multiply both sides by dt. So then we'll have mdv equals mg minus bv times dt. Great. So let's see, we have, oh cool, this whole term, mg minus bv. I'm going to go ahead and divide both sides by that and move that to the other side. So it's mgv minus bv, mg minus bv. Great. So this cancels out here. So it's mdv equals mg minus bv equals what? dt. Cool. And that looks pretty good. M right here for the mass is just like a constant, so I can either leave it here or divide it to the other side. Totally your call on what you want to do. I'm just going to leave it there for now. Great, so I go ahead and separate it. So now our next step is integrate. Always write that you're integrating, like communicate that to people. Great. So now, okay, we can go ahead and do the integral. This is going to be fun. So Let's see, right-hand side, that looks pretty darn easy. Integral of dt is just going to be t plus a constant c. Other side looks a little bit trickier. I'm going to go ahead and do u substitution. I'm going to put it in a different color just to see. So u equals what? mg minus bv. So du equals, mg is just constant, so those just disappear when I take the derivative. Take away b dv. Great. So if I solve for dv, oh my goodness, and v's and u's look alike, this is getting tricky. So du over negative b is going to be equal to dv. Great. So now let's go ahead and plug that back in. So m is just the constant, so I can just leave that there. So it's m over mg minus bv, that's just u. And dv is going to be du divided by negative b. Wow, that's sloppy. Okay, so I'm going to go up to the other side of this paper and go ahead and keep solving. First thing on the left-hand side integral, I'm just going to pull out any constants. So those are just because everything's multiplied and divided by everything, so we can just pull them out. So that's negative m over b times integral of 1 over u du equals t plus c. Okay, so now what I'm going to go ahead and do is I can integrate that. Integral of 1 over u, I know from just all my good old practice, it's just going to be ln of absolute value of u equals what? T plus c, and I can't forget about my constants, negative m over b up front. Now let's go ahead and just plug in what u was. So u was mg minus bv equals t plus c. Great. So next thing that we'll need to do, we just integrated. So we're going to need to, oh my goodness, I forgot to write the term ln. Silly mistake galore. Okay, so that's great. Okay, so now I'm good. So now we're going to need to solve for v. We want to find that as a function. So to solve for v, first we need to get the whole ln term by itself. So I'm going to multiply both sides by negative b over m. So we'll have ln, no, my writing's getting sloppy, apologies. Okay, ln of mg minus bv equals, and again we multiply both sides by negative b over m to cancel that out on the left-hand side. So we have negative b over mt plus negative b over mc. So I want you to keep in mind, this whole term right here, b over mc, b is just a constant, m is just the mass of the thing, that's a constant. That is just a new constant. I'm just going to call it c. I don't want to keep writing the same thing. So this is negative b over mt times ln of mg minus bv. Great. So we're not quite done yet. I'm going to go ahead, write down this last little thing. I'm going to go ahead and scroll to some new paper, and then we'll be back in business. Okay. So now let's go ahead and keep solving. So again, we're solving for v. So we have ln all by itself. So to get rid of the ln, we can raise both sides to the e power, because e to the ln just kind of cancels out. So we're left with mg minus bv on this side, and on the other side, that's going to be e to the negative bmt times e to the c, using our exponent rules. And again, e to the c, that is just another constant. E is a constant, c is a constant. We get a new constant. I'll just call that new constant c. So we have c e to negative b over mt, and the other side, that's mg minus bv. Great. So we're still just solving for v, so I can go ahead and do some math. So negative bv equals what? ce to the negative b over mt, take away mg, divide by negative b now, b, so we have v of t equals what? I guess I could just write it like that, ce to the negative b over mt, take away mg over negative b. I feel like I have slightly too many negative signs, so I'm going to distribute the negative signs. So then we're left with mg minus ce to the negative b over mt over b. Great. So this right here is our velocity function. So now for our differential equation steps, let's go to our last two steps, 6 and 7. And again, always keep these steps handy. So let's use our initial conditions to solve for c. So that's step number 6. So I'm going to write that up here. So solve for c. Great. Okay. So our initial conditions at t equals 0, and we can scroll up to the problem and see what happens. At t equals 0, we know the object started at rest, so the velocity is 0. Great. So let's go ahead and plug that in. So into the equation that we just solved for. So we have 0, let me just write the equation right here, equals what? mg minus ce to the negative b over mt over b. Great. So let's plug it all in. 0 equals mg minus ce to negative b over m times 0 over b. Great. So 0 equals mg minus e to the, it'll just be 0, it's just 1. So this is just c times 1 over b. Okay, I can multiply both sides by b. B says toodaloo, and multiplied by 0. So we have mz, blah, 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 I can't talk. Great. So then we just have c equals mg. Cool. We just solved for c. So now what we can do is let's go ahead and plug back c back into our final equation. So let's just go ahead and take this and plug that back in right here. And then we can just rewrite our equation. So our final answer is going to be v of t equals mg minus mg e to negative b over mt over b. And I feel like just for fun factoring out that mg from the top. So it's 1 minus e to the negative b over mt over b. Voila, we got our answer.